So we're moving on to McGlade and Ekins. And so now we're saying, okay, let's assume we've done our IAM stuff and we've come up with that for the time being we're going to be thinking the social cost of carbon is like 50, 100 bucks a ton. What would then the social planner do if that's the case? What allocation of resources would the social planner use? And the biggest question is, of course, how would the social planner allocate fossil fuels? What would we do with these vast fossil fuel stocks we've got in the ground? And this is the question that McGlade and Ekins try to answer. So this is like a really important paper actually in getting a grip on the social planner's economy. Should have been done a lot earlier. So we're going to look at the three figures in this paper. And I'm just going to pause there to collect my thoughts. Okay, so figure 1 is basically showing stocks of oil, coal, coal, oil and gas. Okay. And for reasons best known to themselves and the referees who didn't pull them up on this, they've chosen different units for these stocks, which is absolutely crazy. But it turns out they then start using this unit called a zettajoule. And it turns out that this one, oil, out here is about 7 zettajoules. Gas out here is also about 7 zettajoules. And, sorry, I'm going to have to stop the video here. Okay, I had to stop for a thing there because I realized I was going to misrepresent what they had done. It's just super confusing this with the different units they're using. But basically what they say is, if we do everything in zettajoules, that reserves, like the stuff we know about, there's about 7 zettajoules of oil, 7 zettajoules of gas, and 20 zettajoules of coal. Okay. But there's also probably out there, in each case, that's probably about a third to a quarter of what's out there altogether, the reserves. Okay. And this is showing the relative emissions that would flow from using up all that stuff. So the emissions from gas, even though this is 7 zettajoules and 7 zettajoules, the emissions from gas are lower because gas is less emissions intensive per energy unit produced. Sorry, this is CO2 emissions. Okay. But what we also see here, this is what I wanted to talk about really, not get stuck on units. Well, one thing is there's a hell of a lot more coal out there than there is oil and gas. Okay, that's an important point from this. A lot more coal, both in terms of the energy that we can produce and the resulting emissions. The next thing is that we've got this curve, upward slope in the extraction costs. Okay, so the resources are available at different extraction costs. So this is like Saudi oil, stick a pipe in the ground and up it comes. It's more or less free to extract. Then we've got like North Sea oil somewhere up here. We've got Albertan stuff and so on. Yeah. And similar for gas, like shale gas is clearly more expensive to extract than gas, which you find together with oil. And and so on. And obviously, coal is available in very different quantities. There's places where you can just shovel it up in hundreds of tons at a time. There's places where you have to dig deep down underground in narrow seams. Okay. So then the question is, in first best, what would the extraction profile look like within each type? Obviously, in first best, we would start with the cheapest stuff and then work our way down or up in terms of costs. It's kind of obvious, and you're going to do it basically because of discounting. Why would you take this stuff before this stuff? It would be crazy. But of course, this is exactly what we're doing in the current economy if we move away from first best, talking about first best for a minute, because we're extracting Saudi oil, North Sea oil, and Albertan oil at the same time, right? And that's to do with market power, which we'll talk about later. But that's an obvious diversion from first best, isn't it? Okay, that's figure 1. I'm going to pause there and we'll go on to figure 2. So in figure 2, what they've basically done is run lots of simulations with partly using the costs, the cost curves from figure 1, and assuming that you start with the cheapest and then work your way up, and then assuming that we're minimizing costs within some carbon budget. Okay, so this is a planner's scenario, minimizing the costs. There's no OPEC here, it's all based on the extraction costs, not the market prices given market power, etc. Okay, so this is a planner's scenario or a first best scenario. And of course, what we end up using will depend on the damage function, or in this case, they just put different restrictions on the total emissions that are allowed. And the green ones here is a tough restriction, not very much emissions at all. The orange is not so tough, and the red is quite a loose restriction. So let's just look at the green one. What does this show? So the dots are like for different simulations, for different models and so on. I can't remember exactly, but they end up saying like this is a reasonable average. And so this is saying, look, roughly 3 zetajoules of coal will be used and 6 or 7 zetajoules of gas. And again here we've got 3 of coal and again 6 or 7 of oil. And here we've got 6 or 7 of oil and 6 or 7 of gas. So actually this third one is redundant. All the information is in 2 of them. So, if we think back to the previous figure, what's this saying? We're only using 3 zetajoules of coal. The stocks we already know about are 20 zetajoules, and that was only about a third or a quarter of what we think is out there altogether. Okay. So basically, we're leaving almost all the coal in the ground in first best. Okay. Meanwhile, oil and gas, we're more or less using 6, 7, even 8 zetajoules, which was about equal to the known reserves at the moment. So we're going to extract an amount that's roughly equal to what we know about today. It might not be exactly those reserves, we might discover other cheaper stuff, but more or less in first best. So that might surprise you. We're basically going to use up all the oil that we know about. And gas, but hardly any of the coal. That is first best. Okay, and almost certainly then the Albertan stuff would end up staying in the ground because we'll discover other cheaper oil. So that's what figure 2 is telling us. That's the key figure here. And I'm going to pause again there. sorry, actually figure 3 isn't that important, we'll skip it. Let's just look at the table. Carbon capture and storage, no carbon capture and storage. Let's assume no carbon capture and storage. These percentages are saying how much gets left in the ground, basically. And at 2050, so by 2050, we've still got a fair bit of oil left in the ground and a fair bit of gas, but we've got almost all the coal is left in the ground. Okay, so this is first best fossil fuel exploitation. Stop burning coal.